Alright guys, this is the video lesson for 10.4, graphing quadratic functions. As you see here, there are a lot of definitions that we need to go over because there's lots of terms you will hear in this section that you need to be familiar with. So what you need to do right now is go ahead and pause the video and copy down all these definitions. And you definitely have to pause the video because I'm going to be switching to the next page right now, and so that you can copy down the next set of definitions. So definitely pause the video and copy these down. Okay, and here are the last three definitions along with an equation for your first page of notes, which are all definitions. So again, once again, pause this video, copy down these definitions before we move on. Okay, now that you've got all the definitions copied down, I want to go back and I want you to listen to me explain some things. The quadratic function is an equation of the form y equals ax squared plus bx plus c, and in a quadratic equation is the same thing, but instead of y equals, it says equals 0. So again, it's a quadratic, okay? It's a function if you don't know what the other value or that y value is. It's an equation once you've filled in that y with a number and then made the equation equal to 0. So in other words, if y was 5, then you got to subtract 5 on both sides to make it equal to 0, and now it's a quadratic equation. Okay, parabola is the graph of a quadratic function or a quadratic equation where it equals 0, or if it just says y equals, you're going to graph out your parabola, and I gave an example there of what it looks like. The minimum refers to the lowest point on the graph of a curve, and in our situation here, the only graph of curves that we're dealing with are parabolas, so it's this point right here that is, the lowest point on that graph of a parabola. And then in the reverse of that, the maximum is the highest point on the graph of a curve, or in this case on the graph of our parabola, that point that's the very top point, or the highest point of the graph. The maximum, or the vertex, is the maximum or minimum point of a parabola. So in this example up here, the maximum, or the vertex was that minimum point, and in this graph down here, the vertex was that maximum point. So the vertex, you can also kind of think of it as the very center of your parabola. All right, then on these last definitions, the axis of symmetry is the vertical line containing the vertex of a parabola. And actually, I want you to now add this because I want to show you what that's going to look like. If my parabola is graphed like, let's say, like this, and my vertex is right here, my axis of symmetry is this vertical line. We usually make it a dotted line because it's not really part of the parabola. It's just this invisible, imaginary vertical line right down the center of the parabola. This equation right here is extremely important. You will be using this equation, so that equation there is how you find the axis of symmetry. X equals negative b over 2a. We'll be dealing with that more here in a minute. And then the roots and the zeros, both of these definitions are both really just ways to say the solutions to a quadratic equation. These are the solutions to a quadratic equation, or the x-intercepts. And what you're going to learn in this section is the solutions to a quadratic are the 2 points where they cross the x-axis. So those will be your solutions, or your zeros, or your roots. They all really kind of mean the same thing. All right, let's move on. Okay, so here you go. Here are the steps to graph a parabola. There are 5 of them. I've changed up. 3 should have had 2 bullet points and not 4 having 1 bullet point, so I changed that on your worksheet. You can change it the same way I did it. Again, pause this video, copy this all down, because we are going to move on right now, and then we'll explain these steps as we start to do some of the problems. So copy this down, because we are moving on right now. Okay, so now that you've paused the video and gotten the steps down, right underneath those steps on the rest of this blank page, I want you to write this out. Set this problem up. Here is your problem. So write this down, and then we are going to have steps 1 through 5, and I've given the answer blanks here for steps 1 through 5 because technically each step is going to be counted as an answer to these problems. And then also I have a graph ready to go here. We're just going to sketch it out. Again, I'm going to probably just use little dashes here. Whereas you can see on the back page we'll actually have grid paper, which we'll want grid paper for the rest of these. So get this all copied down, and then we're going to go back and look at how we do this problem. So pause the video again, get this copied down, and we'll continue. Okay, so we're going to work through this step by step. So for step 1, it says to find the axis of symmetry, and we are going to use this equation. Okay, we're going to always use that equation to find the axis of symmetry. So in this answer blank number 1, we are going to write x equals, now again up here with your problem you have to be able to tell me what your A, your B, and your C is, just like we have earlier. So A is 1, B is 6, and C is 5. So for the axis of symmetry we have negative B, so the opposite of B, which is negative 6, over 2 times A. So we have negative 6 over 2. So for our answer here, and I'm going to put the answers in red, for the axis of symmetry our answer is x equals negative 3. Now what you do with that is you actually draw the axis of symmetry. In our definitions you were told that the axis of symmetry is that vertical line that goes right down through the center of the parabola. So the very center of the parabola is going to be right here at negative 3. Okay, so I draw a dotted line there representing the center of the parabola. Now I don't know yet if this parabola is going to look like this, or if it's going to look like this, or if it's going to look like this or this. You know, I don't know any of that yet. I just know that's where the center of the parabola is going to be. Alright, now we go back up to our steps in step 2 here. Step 2 says to find the vertex, and we do that by plugging in the axis of symmetry answer into the original equation. Okay, well that seems easy enough. So we'll go back to our problem here. And since this answer says x equals negative 3, I'm going to simply plug that in for my x's. Now, here's also where you need to understand that this is equal to 0, but our 0 over here is really our y. Okay? So the 0 and the y are kind of the same here. So when you plug negative 3 in for this equation, you're really solving for y. You're trying to figure out what your y is. So y equals, instead of x squared, I'm going to say negative 3 squared plus 6 times negative 3 plus 5. So y equals negative 3 squared is 9 minus 18 plus 5, which that should give us our answer here of y equals, what is that, negative 9, negative 4, right? Now, y, oh, that didn't show up yet. Sorry, having some problems here with the program. So we've got y equals negative 4 from all of that work. But remember, answer 2 is the vertex, and the vertex is an actual ordered pair. Well, your ordered pair now is x is negative 3 and y is negative 4. that is your vertex. And I am going to now graph that vertex. So -3, -4 would be right here, right? -3, -4, vertex, graph it. All right, very good. Now let's go back up to step 3. So looking here at step 3 says to decide if the vertex is a maximum or minimum point. And that's all based on this right here, your A. If A is a positive, your parabola is going to open up, making the vertex a minimum. If your A is negative, your parabola is going to open down, making the vertex a maximum. All right, so again, that seems pretty basic, so I'm just going to go back to my problem here. And what was your A? Well, your A right here was a +1, so A was positive, meaning that this parabola is going to open up. Now again, I don't know how it's going to look exactly. Is it going to be wide like this, or is it going to be real skinny? Bottom line is the parabola is going to open up, and that is going to make my vertex a minimum, and you can just abbreviate that with min. Your vertex is a minimum point, which again also tells you that the parabola is going to open up. All right, so pretty simple so far. Doing this slowly here for our first problem. Step 4, again, if we go back to our notes, and step 4 says make a table. So step 4 and 5 here says make a table and then find your zeros. So let's go back to our work here and see what we mean by make a table. So I've already got a table drawn here, and what you're going to say is you're going to say, okay, well, this is my x value, this is my y value. Now, one thing you've already done in this table is you've already done this once. You've already figured out what your first x was, which was a -3. Now notice I'm going to write -3 kind of here in the middle. And then when you plug -3 into the problem, you found out that y was -4. So this was your first ordered pair, and it was your vertex. Now, I'm doing all these things very specifically because I think it helps you maybe understand and remember some stuff. So I put a little V next to this saying, this is my vertex. Okay, well, other points on this parabola that I don't know what they're going to look like yet, but I know there are going to be points to the right side of the vertex and to the left side of the vertex, right? So what I'm going to figure out is what are the numbers to the right and to the left of my vertex. Well, if this right here is -3, which it is, right, that spot right there is -3 on the x-axis. What is the number just to the right of -3? Well, that'd be -2. Another one to the right would be -1. Another one to the right would be 0. Going the other way, we'd have -4 and -5 and -6. So those are the numbers I'm going to use. Now, I'm going to use all of these right now, so I'm going to end up with 7 points in this table right now. And you see that we only need 5 points. I say up there that you must have 5 points on your graphing of parabolas. I'm going to do 7 this first time, and I'm going to show you why here in a minute. So, in other words, back to my table here, I'm going to say, okay, well, what happens if my x is a -2? What happens if it's a -1? What happens if it's a 0? What happens if it's a -4? What happens if it's a -5? What happens if it's a -6? And now all you have to do here is you have to go in and plug these numbers in, these x's. You're going to take all of these x's and you're going to plug them into the original equation. Okay? Now, looks like a lot of work, and it's not really that much work, and I'm going to show you why. All right, let's start here with the -2. So I'm going to plug -2 into my equation. I'm going to do my work up here in the top right-hand corner of this because I got a lot of work steps here. So I'm going to plug -2 into the equation. I'm going to say y equals -2 squared plus 6 times -2 plus 5, and I'm going to work it out. -2 squared is 4, 6 times negative 2 is negative 12 plus 5. Y equals negative 8 plus 5. So y equals negative 3. So I go back to my table down here and I say, okay, when x was negative 2, y is negative 3. That's an ordered pair. I'm going to go over to my graph. Erase these arrows. And I'm going to graph the ordered pair negative 2, negative 3. So negative 2, negative 1, 2, 3 is going to be right here. Now, one thing that makes this easy is that this axis of symmetry means that everything that's on the right side is the same that's on the left side. This is a symmetric graph. So that means that there is a mirror image ordered pair over here just right on the other side of this. So if this point right here is just one space away from the axis of symmetry this way, there's going to be another point that's just one away from the axis of symmetry this way, meaning right there, meaning these 2 points are mirror images of each other, which means what is the ordered pair of that point right there? Well, it's negative 4, negative 3, which shows you down here that this negative 2 will mirror with the negative 4, giving you negative 4, negative 3. And you can see that that's why I write these numbers in the graph like this, is that negative 2 is going to mirror with negative 4. What's negative 1 going to mirror with? Well, it's going to mirror with negative 5. What's 0 going to mirror with? Well, it's going to mirror with negative 6. So you actually only have to do half of the work, because the other half you can get by simply mirroring the image over. Okay, so we've got those 3 points right now graphed. I'm going to come back up here into my work problem, and I can now either use the negative 1 or the negative 5. I know they're going to give me the same answer. I'm going to obviously choose the smaller number. So I'm going to use negative 1. And again, up here in my workspace, I'm just going to do another problem. Y equals negative 1 squared plus 6 times negative 1 plus 5. Y equals 1 minus 6 plus 5. Y equals negative 5 plus 5, so y equals 0. So again, when x is negative 1, y is 0. And that's the mirror image of when x is negative 5, y is 0. So I plug in those, or I graph those now. Negative 1, 0. Negative 5, 0. So now I technically have my 5 points that I need. But the reason I did one more point here is I wanted to show you how easy, if you can use 0 for your x, like we are getting ready to right here. If I can use 0 for x, that makes the work step up here really easy. You don't even really have to show me the work for a 0, because you have y equals 0 squared plus 6 times 0 plus 5. Well, 0 squared is 0. 6 times 0 is 0. So whenever you plug 0 into these equations, you end up with just whatever your c value was, which in this case is 5. So when x is 0, y is 5, mirrors with negative 6. So negative 6, you also have a positive 5. And I'll go ahead and graph those ordered pairs too. So 0, 5 would be 1, 2, 3, 4, 5 right here. And that mirrors over here with negative 6, 5 right there. And so now you just connect these dots and you have your, kind of missed it there. You have your parabola. Now, last answer blank up here, answer blank 5, and we said step 5 was to find your roots, or find your solutions, or find your zeros. And we learned that the roots of a quadratic here are simply where the parabola crosses the x-axis. So where did this parabola cross the x-axis at? It crossed at negative 5 and negative 1. So your answers here are x equals -5 and x equals -1. So those are your two answers because that's where it crosses. Now, there's actually a lot to say about those solutions because, you know, what happens when they don't cross the x-axis? Or what happens if the parabola doesn't cross at a nice whole number? Or are there other ways to find the answers? And yes, and I want you to actually add this down here, the other ways to find the roots or the zeros of a quadratic is by either you could factor the problem, which in this case, this problem would have factored pretty easy, x squared plus 6x plus 5. Factoring the problem will give you your answers, x equals something and x equals something. Or you could complete the square, which I don't hardly ever recommend doing that. That's one of the harder ways to do it. Or what I recommend probably the most is just use the quadratic formula. You already have your a, b, and c. Plug those numbers in to the quadratic formula and figure out what x equals. In this case, x would have equaled -5 and x would have equaled -1. All right, so that concludes the first video of this lesson. The next video, part 2, will be all just examples. We'll do 4 examples just like this, going through the 5 steps, only we won't spend quite as much time going into quite as much detail. We'll just bang out the 5 steps, so have those steps in front of you so you can follow along as we go through them.